Next up, we're going to hear from Talia and Satish from the Verizon team, and they're going to give us a little bit of a peek beneath the surface of their design system and how they've been approaching variables in the Verizon design system. So with that, welcome Talia and Satish.
I'm Talia Fisher. I'm the lead design system lead at Verizon.
And I'm Kshitish Tembe. I'm a lead experience designer with the Verizon Design Systems team.
Verizon is one of the largest communication technology companies in the world. It's based in the United States and has a legacy that dates back over 40 years. Due to its size and its historical evolution, Verizon has a large matrix org structure with many teams spanning the globe to support its expansive digital footprint. When we first started working on the design system, we were challenged by the ways that the different lines of business had been operating pretty independently with different processes, tech stacks, and application of our brand visual identity. Since then, we've seen a strategic and cultural shift to integrate and unify these digital experiences across lines of business, which has been a great opportunity for us to position the design system as a vehicle for achieving these goals. Ironically enough, the scale and silos of the organization that initially challenge us are exactly why having a design system at Verizon is critical to being able to efficiently build and maintain digital experiences at scale. So the work that we do to increase design system adoption allows us to have a material impact on the company's bottom line. Verizon's core customer base is incredibly diverse, spanning all demographics and levels of comfort with technology. That's an important consideration for our team, given the essential services that Verizon provides to its customers. Being able to pay one's cell phone or internet bill online is something that all customers should be able to do easily. So accessibility is a top priority for us. In fact, our two core values of the Verizon design system are adherence to brand and accessibility standards. This is largely because when we first began our work on the design system, also known as VDS, back in 2019, there was a lack of adherence to these things, and that was at the top of our list of problems to solve. Because of this, we established close partnerships with these teams from day one, and they've been some of our strongest advocates since then. What makes these partnerships special is the two-way nature of how we collaborate. VDS not only adopts the standards set forth by these teams, we can sometimes influence these standards directly. For example, last fall, when we sought to expand and systematize the brand color palette for data visualization within digital, the brand team ended up adopting our color palette changes at the parent brand level to align. This was a case where digital drove a change that would cascade to all of their channels. And actually, next week, we are releasing a video player component that, through close collaboration with the accessibility team, will end up driving updates to Verizon's accessibility standards for video content across the board. The Verizon design system started out supporting responsive websites with a React component library. We primarily cater to customer-facing experiences across consumer and business segments, but we're also highly utilized across many internal tools. We're currently in the process of building out code libraries for native iOS and Android platforms that correspond with our existing Figma design library. VDS has come a long way in the almost 5 years since it's been around. Our initial beta release in 2019 established the concept at Verizon of a design system that aligned design and code assets. 6 months later, we released our V1 that introduced the accessibility-driven tweaks to color and typography while systematizing and optimizing our core component set. And in 2022, we released a new generation of the library that featured a significant update to our brand visual identity, including certain considerations for digital, such as using dark color schemes to emphasize key brand moments. Other notable features of this version were our incorporation of design tokens and our migration to using Figma as our official design tool. Since then, we've been continuing to release new features from our backlog, but in January of this year, we released a major Figma library update that included the introduction of variables, which Kshitish will be walking us through.
In order to understand the approach behind implementation of variables and modes, it is imperative to understand how things used to work in VDS. At Verizon, we use dark versus light UI not in the service of user control dark mode, but in order to create emphasis and highlight key brand moments within experiences. The UI can be all dark or light or use a combination of both, and VDS supports this use of colors with two options for surface, which are light and dark. And to support these surface options, we created two sets of color styles, which are on light and on dark. On light color styles are meant to be applied to elements and components which are placed on a light surface. And on dark color styles are meant to be applied to elements and components which are placed on a dark surface. We extended the same logic to our components, where the surface prop controlled the visual appearance of the VDS components by rendering them in either on light or on dark color styles. But this way of working essentially meant that whenever we were working on creating a new variant grid or updating an existing one, we would have to do the work twice to cater to the light and dark surface. This not only impacted our way of working, but also affected our adopters. It was quite easy to design for light surfaces as all the components were defaulted to light. But for someone who's working on primarily dark experiences, they would have had to select these components and then individually change the surface from light to dark. Also, they would have had to change the color styles for page and section backgrounds. This way of working was quite cumbersome and took a lot of time. But this changed with the introduction of variables. When Figma launched these features, we did a thorough assessment to understand how we can benefit from them and identified two goals. First, we wanted to align variables with the code token structure, and the second was to replace the surface prop with surface variables. And we achieved this goal by creation of 5 variable collections. Of these 5, 3 collections were form control, shape, and layout, which controlled the spacing and shape definition. And by creating these 3 collections, we were not only able to replace the hard-coded values which were prone to human error, but also align ourselves with our coded counterpart, as spacing and shape tokens always existed in code. And this was the first time we were introducing the same concept in a design tool. The next 2 collections are VDS palette and VDS surface, which are meant for colors. Let's take a closer look at how we have structured them. Our first collection is VDS palette, which consists of all the primitive color variables. This collection is surface agnostic, and its variables have only one definition associated with them. And this definition comes from our brand approved hex values. We seldom use these variables in our components as they're reserved only for elements which are agnostic to surface change. The next collection is called VDS surface, which consists of semantic variables. This collection has 2 modes associated with it, which are light and dark. Hence, the variables have 2 values which correspond with these modes and are mapped to the VDS palette variables. When the surface variables are applied to a component, it becomes responsive to the mode change. If the component is placed on a surface with light mode, it will get rendered in the values associated with the light mode. But if it is placed on a surface with the dark mode, it will get rendered in the values associated with the dark mode. This mechanism is exactly the same as how Surface Prop used to render components in on-light and on-dark color styles. But the biggest difference is we are achieving the same outcome with just one color variable. Let's take a look at how this mapping got translated into Figma's collections. First up, we have VDS palette, where we have named the variable groups on the basis of the colors inside them. And the variables in these collections are named on the basis of the lightness value if expressed in HSL color space. HSL stands for hue, saturation, and lightness. And the values of these variables come from our brand-approved hex codes. Next up is VDS surface, where we have named a variable group on the basis of their intended application. And the variables inside this group also follow the same logic. But this collection has 2 modes associated with it, which are light and dark. And the value for these modes are mapped to palette variables. And by creating these variables and collections, we were able to achieve our second goal of replacing surface prop with surface variables. Now our adopters no longer need to select the components and then change the surface prop individually. They even don't need to change the page and section background, as now everything is controlled by modes. When we started working on implementation of variables, we also started to work in parallel on assessing the impact it will have on our adopters. And we realized that by introducing surface modes, we are essentially introducing an entirely new mental model for surface control. And at the same time, we are deprecating the color styles and the dark surface variants, which were foundational to the previous mental model of surface change. We felt that our existing robust design documentation wouldn't have sufficed. And we wanted to create something which would have enabled our adopters to learn these concepts and experience the mechanism behind it. So we created Color Variables Playground, which consisted of a great mix of educational content and hands-on activities which made it easy to apply the learnings on the go. Let me show you a few excerpts from our first walkthrough to our adopters. We wanted our adopters to experience the mechanism of surface change firsthand. So we created a sample web page which had some of the most commonly used VDS components like tiles and title lockup. And we asked them to place this page inside container, which was set to the light mode to experience the default mode. Then we asked them to move the web page to the container on the right, which had dark mode applied to it. And as soon as they moved it to the dark container, the colors changed, which created a moment of delight and sparked general curiosity to learn about how did this happen. And this gave us a great segue to talk about how surface is defined, like what design elements can be considered as a surface. Composable things such as page, image, section, and tile, from non-composable components that can only be configured like notification and button. We also wanted them to experience how to apply a mode not just at a page level, but also on a section and tile to understand the new mental model and create the interplay of light and dark surfaces, which defines Verizon's visual appearance. Overall, the color variable playground was quite successful in educating our adopters on the foundational concepts behind the new mental model, and also became an important artifact in our designer onboarding kit. Let's move on to our next challenge, which was deprecation of color styles and variables. We knew that deprecation is, if not done correctly, will result into massive breaking changes and will disrupt the workflow for our adopters. So we set out two goals for us. First one was to minimize the breaking changes, and the second one was to minimize the friction while accepting these library changes. And we achieved these goals by re-architecting our variant grid. We separated the dark surface components into another variant grid, and we kept the light surfaces as is, and replaced their color styles with variables to make them responsive to the mode change. We also removed the surface prop from the variant grids. And on the dark surface variants, we retained the color styles as we didn't want them to respond to mode change. And by using this method, we were able to retain the links to the already published components, and at the same time got rid of the surface prop without creating any conflicts in the variant grid. The next step that we took was to add the deprecation indicators by pretending the names of the color styles and components with cross mark emoji and deprecated text set in uppercase to indicate that these styles and components should not be used. But we felt that this was not enough to indicate that components and styles have been deprecated, as this method required our adopters to select the component to identify that it has been deprecated. And if we look at a typical file, it would have hundreds of frames in it, and it would almost be a Herculean task to individually identify and replace these components. So we started to think that what if there was a mechanism which would give our adopters a bird's eye view of all the components which are deprecated and needs a replacement. So we exactly built that. Say hello to our deprecation mode, which gives our adopters a bird's eye view of all the components which have been deprecated and needs to be replaced. Let me quickly show you how it works. So for our adopters, they just need to open their file, accept the new updates. And once they're done with that, they have to go to the page modes, go to VDS deprecated, and click on. And as soon as they click on it, all the deprecated components will get highlighted. And replacing these components is as easy as identifying them. What they need to do is just select the component and replace it with the correct one. Let me quickly clean up this page. And we are done. Now let's look into how did we achieve this. So we created a collection called VDS deprecated with a variable named fill, which had two modes, off and on, with off being the default one. And in the off mode, the opacity of the fill was set to 0%. And in on mode, the opacity of the fill was set to 60%. The next step that we took was to create the deprecated component indicator, which had just one frame with the deprecated variable applied to it. Then we added an instance of the deprecated component indicator to all the dark surface variants, and we absolute positioned it as a topmost layer with the constraint set to all the sides, and then locked the layer to ensure that it doesn't hinder with our adopters trying to interact with the other elements in the component layers. Then right before publishing, we switched off the deprecation indicator as we wanted it to be a conscious choice by our adopters to switch it on. Otherwise, it would have been quite shocking to see all the dark surface components suddenly turn magenta as soon as the library updates were accepted. After the launch of this feature pack release, we immediately experienced the benefits. The time we used to spend on construction of variant grid got reduced by 20 to 40%. And the maximum impact we saw was in testing, where we saved almost 50% of time as we only had to test the architecture once. And as soon as we remove the deprecated components and styles, we are looking at a 50% reduction in the file size. Our adopters also saw the benefits immediately. Swapping between surface was a cakewalk now. It was just a few clicks away. And we also saw our adopters correctly applying semantic color variables, which was an outcome of defining variable scope, which ensured that our adopters only saw relevant variables when a particular element was selected. For example, if they've selected typography, they will only see variables which can be applied to it and will not see variables like background. It was tremendous fun to work with variables and modes as we were able to create a lot of value for our adopters by drastically simplifying their workflow. And with the new upcoming features, we can't wait to simplify it even further.
So where do we go from here? As we mentioned, Verizon's use of dark UI isn't currently in service of a true dark mode. However, the work that we've just done with surface modes in conjunction to the work that we're currently doing to release native iOS and Android code libraries will allow any of Verizon's many mobile applications to more easily enable a true dark mode feature in the future. Many of our components have type size changes across viewports. So the availability of Figma's new typography variables will unlock our ability to explore supporting viewport as a mode instead of a component property. And on a related note, we've had conversations in the past about potentially extending VDS support to include larger displays, such as those utilized within our retail stores. A variable collection for viewport to control space, size, and density could more easily power something like this. There are also other brands under the Verizon umbrella that have their own distinct visual identities, such as Visible. Teams from these brands have expressed an interest in using VDS if we were to add theming support. Variables could very well be used to unlock this capability. So will we pursue some of these things or all of them? I can't necessarily answer that with confidence today, but that's also not exactly the most important thing. What's important is that the work that we just did is foundational, and it puts us in a much stronger position to more easily consider pursuing any of these types of improvements and extensions in the future. And if any of this excites you, you should know that we're currently in the process of scaling up our team, and we're looking for people that want to help us chart this next course. And product people especially, we are looking for you. So thanks everyone for tuning in, and I'll kick things back over to Chad in case we have time for any questions.
Awesome, Talia. Thank you, Talia, Satish. That was fantastic. You know, I just got to say, deprecation mode was a huge, huge hit in the chat. That was fantastic. I think if we really just dive into the deprecation mode for a moment and just deprecation of components in design systems as a whole, I'm curious how the Verizon team approaches this. You know, when a component has been deprecated and you now decide, hey, it's time to remove it from the library. Can you share a little bit about what that timeline is to look?
Yeah, so since we stabilized our library back in 2022, we have occasionally deprecated some styles and components, and we've typically approached those on a case-by-case basis, you know, looking at impact and just to understand, you know, how much it's utilized and using things like Figma analytics. We typically do a deprecation window of 3 months. So from that's the point from when we announce that we're going to deprecate it from when we remove it from our library. And we communicate that across multiple channels. So we have a release email and a release Slack message that all point to release history that outlines all the details of a release. including mentions of any deprecated components, and includes their deprecation window and when they can, when someone should expect to have swapped them out. We also link to instructions on how to do so. But the team, in doing this wider spread deprecation, it did get us to kind of reflect a little bit on our approach to deprecation, and not just how we communicate it, but also even just making the decision to do so. It's gotten us to want to kind of formalize our approach so that we can make, more easily make these decisions in the future. Of course, prioritizing the adopter experience and really evaluating, is this important enough to warrant that kind of a disruption, and really also looking at communications to help give people the confidence when updating accepting those updates, and to also just build that trust between the design system team and our adopters.
For either of you, are there potential use cases that you're really particularly excited about that you would love to explore?
I'm personally very excited about exploring typography variables and spacing variables to replace the viewport prop, as I see the mechanics to be quite similar to how Surface used to work in VDS. And this change will make it extremely easier for adopters to swap between mobile, tablet, and desktop viewport. I think this would even be more impactful than removal of Surface prop.
Cool. And then I think we probably have time for one or two more here yet. The one piece you're sharing in there around how do you enable teams around this, on creating that playground example on how do teams learn about surfaces, thinking about existing adopters as well as other cross-functional partners. I'm curious, have you found success with that playground being a great onboarding resource for those who are either new to the design org or really any other cross-functional partners at Verizon?
Yeah, this was our first time creating a playground file like this, and we found it incredibly effective as an education and training tool. It's something we want to start doing more regularly on an ongoing basis. I think, the design tools have gotten better and better, in my career for sure. And I think as we continue to leverage, all that Figma is capable of, it becomes, much more important to help people learn how to use these things. I think our adopter base there's kind of a wide spread of tool proficiency. And so as that happens, it becomes more important to be able to help people take advantage of all these capabilities that you've built into the design system. So for us, the playground is a great strategy for helping to do that. So we plan to do a lot more of that this year and going forward.
Well, Talia, Satish, thank you so much for sharing.